Hello guys, it's me again. Welcome back to my channel, which is Tech and Non-Tech with Sumit Ohdar, with the 5th video lecture series of machine tool. I hope you guys are enjoying the videos, and if you haven't watched the last 4 videos, please do watch it and come to the 5th videos. And if you are new to my channel, please do subscribe it, and also don't forget to press the bell icon. You can follow me in my social media, Facebook and Instagram, for more updates. So let's start the video without wasting the time. So today our topic will be milling operations. So milling operation, which is also another important of various exams, like for university exams as well as for the competitive exams as well. So we'll just look into it. Okay, so various milling cutter. Out of various milling cutter, the important one is like for end milling cutter, side milling cutter, gang milling cutter, peripheral milling cutter, straddle mill cutter, form mill cutter. So these are the mill cutter which we'll look into one by one in the coming video lecture series. So now let's proceed. Now the main application of the milling is, it is used for the gear cutting process, thread cutting, dovetail recess, and for slots making. And so these are the important application of the milling operations. Okay, then for the milling machines, so these are the milling machines: universal milling machine, rotary milling machines, vertical milling machines, horizontal milling machines, planar milling machines. So in the competitive exam, they are not going to ask what is the milling and all that. So these are the milling machines which will important for the university exam purpose. So I'm not gonna discuss in details about the theory of these milling machines. If you are ongoing like second, third or fourth year students, and you have these topics in your syllabus, then you don't have to watch this video. For theory, you please do refer any standard notes or any faculty lecture note or any standard book, which that only going to help you in the university exam. So here I'll be dealing based on the competitive exams point of view. Okay, so I'm not gonna discuss about these milling machines in details. So these are the milling machines. If you need theory about it, you please do refer any of the manufacturing notebook or production engineering book, where you will be getting all the theory related to these machines. So for some milling process, what are the milling process means, for what purpose this milling is used: for the facing purpose, for the slot making, which also slot milling, helical milling, is saw milling, angular milling, and then slab milling. So this also milling process will be looking one by one in the coming video lecture series, and some of or few of them I'll discuss in this video lecture series. Okay, so the end mill cutter. So this is how the end mill cutter look like. So this is the milling cutter, okay, which rotates about the vertical axis. The helical grooves made on the surface of the milling machines. Okay, so this is the end mill cutter. It is used for the slot making. So this is how the slot we make. Slot end mill cutter will cut on the workpiece. So this is how it cuts on the surface of the workpiece. This is called slot milling by the end mill cutter. Once again, this is called slot milling by end mill cutter. Okay, so face milling also by the end mill cutter. So end mill cutter is used for the slot making also and for the face milling also. Okay, so we'll do the analysis on the face milling. For the face milling, the top view of the workpiece and the cutting end mill cutter is this one. This is the workpiece and this is the end mill cutter diameter. Okay, so D is the here diameter of the cutter and W is the width of the workpiece. Okay, here D is diameter of the cutter, W is the width of the workpiece. And face milling, there is two types of the face milling. One is symmetric face milling and second one is asymmetric face milling. Okay, we'll look both one by one. So first what is symmetric face milling? What is symmetric face milling? So symmetric face milling is that where the cutter center of the cutter exactly passes through the central axis of the workpiece. That is called symmetric face milling. Once again I repeat, the symmetric face milling is where the center of the cutter passes exactly the central axis of the workpiece. So symmetric face milling, cutter center passes along the central axis and workpiece. Cutter passes through the center of the workpiece. This is main point for the symmetric face milling. So this is the workpiece over here. This is the workpiece and this is the end mill cutter. Okay, so here we have to do the analysis. Here also we have to find machining time. Okay, for the machining time we'll do the analysis in details of this workpiece and end mill cutter. So before I do, just let me explain what is. So cutter and this is the workpiece. Okay, so we have to find what is this X. Here X is the allowance, means this X distance has to move the cutter so that the entire surface of the workpiece will get milled. So that X distance, until and unless the cutter is not moving that X distance, the entire surface of the workpiece will not get milled. Okay, so we need to find what is that X, what is that compulsory allowance. Here X is known as compulsory allowance. So from the geometry, what is AB here? AB is equal to X. This is the AB is equal to X, which we can write OB minus OA. This distance, total OB minus OA, will give us what is X. Okay, now OB is the radius of the cutter. From the geometry you may not feel like it is radius of the cutter, but OB is exactly the radius of the cutter. So we can write it OB is equal to D by 2, and OA we can write it from the Pythagoras theorem. From this triangle we can write OA is equal to OC square minus OA square. This is OA square. Okay, so again what is OB? D by 2 minus again OC is the radius of the cutter, which is D by 2 whole square, and AO square is width of the workpiece divided by 2, which is W by 2 whole square. Just write over here and solve it. We'll get that compulsory allowances for the symmetrical face milling is, which is X symmetrical is equal to 1 by 2 into D minus D square minus W square under root, where D is the diameter of the cutter and W is the width of the workpiece. So this is the important formula for the symmetric face milling operation. Okay, so please you remember this one. What is the compulsory allowances for the symmetrical face milling? You need to remember this equation. X symmetric is equal to 1 by 2 into D minus under root D square minus W square. Okay, this is one formula. Now moving on, we'll talk about the asymmetric face milling. From the name itself we can say what is the asymmetric means. Here the center of the cutter will not exactly pass through the central axis of the workpiece. So there will be some offset between the central axis of the workpiece and center of the cutter. So that offset distance we need to find, means that what is that offset Y we need to find from the geometry. Okay, so X is equal to, again we need to find what is that X distance, means that cutter has to move this compulsory allowances to complete the asymmetrical face milling. So X, again we can write it from the geometry. X is equal to AB is equal to OB, from the geometry OB minus OA will give you the X. Okay, OB is again here radius of the cutter, which is D by 2, and OA from the geometry, from this triangle we can write it OC square minus AC square, and AC over here will be offset plus width of the workpiece, half of the width of the workpiece, which will be the AC. Just substitute these two in this equation, and solve it. We'll get the compulsory allowances equation as x asymmetrical is equal to half into d minus under root d square minus w plus 2 times of the offset of whole square. Okay, again I repeat, compulsory allowances for the asymmetric mailing is half into d minus under root d square minus w plus 2 times of the offset whole square. Okay, whole square. This is the compulsory allowances for asymmetric face milling. Okay, we have to find again what is the machining time in the symmetric and asymmetric face milling. So machining time formula is given over here. Please remember this one, which is very important for solving the numerical problem. So what is the machining time? From the previous lecture also we know equivalent length, effective length divided by the feed velocity. Here feed velocity is what? Feed velocity is equal to ft into z into n. So what is ft, what is z, what is n? Here ft is feed per tooth. Okay, so here is tooth is there, right, in the milling cutter. So feed per tooth, z is the number of teeth, sorry, once again I repeat, ft is the feed per tooth, z is the number of teeth, and n is the revolution per minute, means speed of the cutter or spindle, we can say that. Okay, so what is the ftZn? I told you ft is the feed in mm per tooth, z is the number of tooth, and n is the revolution per minute. Okay, so this is the formula you need to remember, effective length divided by ftZn for the milling. ftZn is here mm per minute. Okay, so we'll just discuss one numericals, how to use this formula for solving the milling questions. Okay, so question, workpiece, a workpiece of 100 into 50 into 25 means 100 length, 50 width, and 25 is thickness has to machined using the face milling cutter of diameter 60 mm and 20 teeth to reduce the thickness to 15 mm. So thickness, initial thickness is 20 mm. Through the milling cutter we have to reduce it or final thickness to 15 mm. Okay, then feet per tooth, which is the ft is given 0.03 mm per tooth, and cutter rotates at 150 rpm. N is given 150 rpm. Depth of cut cannot exceed 5 mm, so depth of cut is 5 mm. D, and machining time, we need to find what is the machining time, so we need to find what is the tm. So what is the tm? This is the case for symmetric face milling, and we know for the symmetric face milling what is the machining time. Effective length, machining time is effective length by ft zn. So here effective length will be what? Length of the workpiece, which is the 100, and plus compulsory allowances means x. We need to find what is the x for the case of symmetric face milling. The formula is over here. X symmetric is this one, so just substitute. Diameter of the cutter is given 60 mm. Okay, width of the workpiece will be the 50. So from this formula we will be getting x 13.14 mm. Okay, so substitute it, we will be getting the machining time 1.26 minutes. So in question it is given it cannot, a depth of cut cannot be exceeded by 5 mm. So from 25 to 15 we need to go in the thickness, so we need to we require 2 number of pass. Okay, so whatever 1.26 minute is coming for the machining time, just multiply it with the number of pass. Number of pass we will be getting the 2.52 minute, which we required for the face milling for reducing the thickness from 25 mm to 15 mm. So this is how you have to use the formula for solving the problem. Okay, this is for the case of symmetric milling. And one simple questions, a milling cutter having 8 teeth, Z is rotating 150 rpm, N is given if the feet per tooth is 0.1 mm, Ft is given 0.1 mm. The table speed in mm per revolution we need to find what is the table speed. So we know the formula, table speed is equal to simple Ft/Zn. This is the formula Ft/Zn. Just substitute all the data given in the questions. We will be getting 120 mm per revolution. Okay, so this is your answer. Okay, I hope you all are getting. If not, you please do repeat the video. And okay, now we'll look another questions which is based on the asymmetric face milling. Okay, we have discussed one questions related to symmetric face milling. Now this one is for asymmetric face milling. So question says a surface 80 into 160 mm, means 160 mm is length and 80 is the width, is rough machined using the 150 mm dia face milling cutter. D is given 150 mm having the 10 teeth. Z is given 10. The cutter center is offset by 15 mm. So here Y value is 15 mm from the line of symmetry, means from the center of the central axis of the workpiece. So estimate the time to rough machine the surface if feet per tooth is given 0.25 mm and velocity is given 20 meter per minute. Okay, remember that when you read these questions, N is not given. So through this we need to find what is the N. So question is clear that this is related to asymmetric face milling. So as soon as you question you read and you get to know that this is which kind of questions, whether it is related to symmetric or asymmetric, then your task is to find what is the compulsory allowances, means you need to find what is the X. Okay, so for asymmetric face milling, what is the X compulsory allowances? X is equal to half into D minus under root D square minus W plus 2 times of offset whole square. Okay, all the data is given over here. Just substitute it. We will be getting 24 mm, which is the compulsory allowances. Now what is the machining time? Machining time is equal to effective length divided by feet velocity, which is Ft/Zn. So what is the effective length of the workpiece is given 160 and compulsory allowances X is 24 mm. We got it just right now. Feet per tooth is given 0.25 mm, number of teeth is given 10 and N is not given over here. Now N we need to find. So we know V is equal to pi D N divided by 1000. Okay, so just manipulate this equation. From this equation you will get what is the N. After finding this N, you just substitute it over here in this equation. So you will getting 1.73 minute is the answer, machining time. Okay, so now next, slot milling. For the slot milling, this is the workpiece over which slot is being made, and this is the milling cutter. Okay, and this is the top view slot, and this is the end cutter, this is the workpiece, this is the width of the workpiece. Remember here the diameter of the cutter is equal to width of the workpiece in the slot milling. So in slot milling, what is the compulsory allowances? You just write the formula of the symmetric face milling. X is equal to half D minus under root D square minus W square. So for the slot making, D and W is the same, so these two will get cancelled out. Okay, so what is the compulsory allowances over here? Compulsory allowances for the slot milling is X equal to D by 2. Okay, so width of the slot, here W is the width of the slot, D is the diameter of the cutter. This formula you need to remember. Okay, this is important for the slot milling. Okay, so we'll look one questions. When milling a slot 20 mm wide, width is given 10 centimeter long length in a rectangular plates, 10 centimeter 20 centimeter length and width is given, velocity is given 60 meter per minute, diameter of the cutter is given 20 mm, number of teeth Z8 is given, feed is given 0.01 mm per tooth, depth of cut is given. We need to find what is the machining time. Okay, this is for the case of slot milling. In the slot milling, the formula would be the same again, effective length divided by F into N. It should be N. We need to find what is the N. Again same formula we have to use, V is equal to pi dn upon 1000, from which we need to find what is the N. Okay, now substitute over here. We will be getting what is the machining time for the slot milling. Remember that here we have to find what is the compulsory allowances, which is coming x equal to d by 2. Okay, d is over here 20, means x equal to d by 2, which is 20 by 2 is equal to 10, which is the x, compulsory allowances for the slot milling. Okay, one more questions. A slab of width 50 mm, a slab of width 50 mm is given and length 200 mm is rough machined by symmetric face milling cutter. The cutter diameter is 75 mm. The length of the tool travel, means we need to find what is the length tool has to move. We know the tool has to move length of the workpiece plus compulsory allowances. So combination of these two will be the length of the tool travel, so which will be the effective length. So this is how we have to find. So length we know, we need to find only what is the x. And also question given, this is the for the case of symmetric face milling. So for the symmetric face milling, what is the x formula? Just substitute over here and find what is the x. In that you just add the length of the workpiece, which is 200 plus 9.95. So this is the answer. So I hope it is clear. Slot milling. Okay, with this I am signing out until we meet again. Till then, bye bye.